this is the member which is extracted out of a complicated structure. And we don't care what is at two ends in terms of support. Whatever support we have, we just clamp both ends. So this is clamp. This is also clamping. After you clamp both ends, it means that you place two fixed support at two ends. So you have a fixed support here, another fixed support here. But originally, the two ends may not be fixed support. After you have this fixed support, depending on the loading on your structure, you have different equations for fixed and moment. So those equations here, if this is point A and this is point B, as a reminder, we have fixed end moment for AB, and we have fixed end moment for BA. So the type of loading could be different. For example, it could be uniformly distributed load. How do you find these fixed end moments? From the table. So you need to refer to the table and find the fixed end moment. There are a couple of options in the table. So you have that table in the final exam. So I will give it to you. Of course, you can include some of them on your crib sheet, but I'm not sure if you are able to include all of them because they occupy almost the entire crib sheet. So I will give it to you as an appendix at the end of the exam. So I'm just trying to remind you that the formula for moment from A to B, we have a formula for moment from B to A. 2EI over L. So, of course, you don't need to memorize it. This is 2 theta A plus theta B minus 3 psi plus FEMAB, if I'm not mistaken. Later we can check it. Theta B plus theta A, 3 psi, FEMBA. So you need to make sure you understand the meaning of moment AB. Moment AB is at point A, moment BA is at point B. And remember, we are using slope deflection equation to analyze indeterminate structures. Because in statics, you were able to solve some of these type of problems, but only determinate structure. So you can see this structure is indeterminate. And we are able to find moment at point A, moment at point B. So, any questions? So this is just to recap what we have discussed so far. I'm just preparing your mind for modified slope deflection. Because you may confuse the original slope deflection with the modified. So now, any question for this? Now, we are going to simplify this equation. So that one is called modified equations for slope deflection. And that modification comes when we already know one end of the member is a roller or a pin.
Question.
Any question? Yes? No? Now, consider this beam. One end is fixed end, one end is a roller or pin. And you have a loading, whatever. We are not worried about the loading because we have the table and we can obtain FEM from the table. So this is A, this is B. And the intensity for the loading, let's say we call it W. Now, if you look at these two equations, MAB and MBA, MAB is equal to 2EI. I'm just repeating this equation. In the textbook, instead of A and B, we call this end as near end. We call it near end, and we call this one as far end. So we have a near end, we have a far end. So instead of A and B, we use N and F, near and far. Any question? And just to make it easier, we just show it with MN. Because you already know what we mean about near and far. So let's show it with N. So the textbook is using MN. So now, 2 theta A, 2 theta N, plus theta far N minus 3 psi plus FEM. So it's just about symbol. FEMN. So you don't have any problem for the symbols, you understand it, near and far. For the second equation, for the far, how much is moment at far end? Remember, this is near, we show it with N, and this is far end, we show it with F. How much is moment at far end or point B? You already know that. It's 0. Because it's a roller or it's a pin. So the modification comes when we have a pin or a roller support. Or maybe we say pin and roller, we don't say support, because they could be inside your knee. So here we have a roller, so we already know the moment at point B. So just to make sure you understand, this is moment at point B, but we show it with far end. So we show it with MF. And let's continue. We write the equation from slope deflection. So it is 2EI 2 theta F plus theta N minus 3 psi. But because we already know that point B or far end is not clamped, it is a roller, the amount of moment is 0 at that point. So we are basically proving the equation for modified slope deflection. So we already know this is a roller, so FEM here is 0.
Do we not need the 2EI over L on these?
Yes.
Okay.
So we are just repeating the equation, the original equation.
Yeah.
Any questions so far? That's a good question. The way the textbook is writing it is like this. So different arrangement. 2E I over L, which is the same. 2EI over L. Any questions so far? So now, from the second equation, we can obtain, we are here. We are going to get rid of theta for F, for B. So we rewrite this equation and we find theta n in terms of theta F and psi. So that is the answer. 3 times psi minus phi minus theta for n divided by 2. I'll give you time to look at it. So, because this side of the equation is 0, you just cancel 2ei over L, and then we have 2 theta F plus theta n minus 3 psi equal to 0. And then from there, you find theta n in terms of psi and theta. You find theta F in terms of theta n and psi. Now, if you substitute theta F here, then you would have the equation for Mn written in terms of Ei over L, theta n, and psi, and Fem. Basically, we are removing theta F. One of the variables is removed because we already have one condition here. So we take advantage of that and we remove one of the variables. So if you substitute it there, Mn, moment at far end, at near end, which is moment at point A, is 2ei over L times 2 theta n. I'm just repeating this. Plus, instead of theta F, I write 3 psi divided by 2. 3 psi divided by 2, I write it in green color, minus theta n divided by 2 minus 3 psi plus Fem for near n. So the green color one is theta F. And then we simplify, theta n and theta n are cancelled, psi and psi are cancelled. So after simplification, the answer is 3 ei over L times theta n minus psi plus Fem for near n. So this is the modified equation that we use. So I'll write it here, Mn so you can see this is much simpler, and we call it modified equation. The reason it is called modified is that we don't see theta F. So this is only theta n, the near one. So we basically removed one of the variables. So it is much easier in terms of calculation. And another thing is you have to make sure is where do you find this FEM? This FEM is different from the one we found in original equation. So the tables are different. So I write it here. Different table.